So this question where f of x, it's very interesting. It seems to be an advanced question. A maximum of 1 plus x plus greatest integer function of x, 2 plus x, and an x plus 2 times greatest integer function of x. They've given this function. Let m be the number of points. Let m be the number of points from 0 to 2, 0 to open bracket, no, close bracket 0 to close bracket 2, at which the f is not continuous. F is not continuous, and let n be the number of points where from 0 to 2 when if f is not differentiable, then the question is m plus n the whole square minus plus 2 is equal to what? Okay, that's the question. And so then first of all we should understand how to redefine the function. In this function is there, this function, so let's call them as this is x plus 2 mod x. So let's redefine them as one is g of x, another is h of x. So it's 1 plus x and the greatest integer function of x. And whenever there's a greatest integer function of x, and to redefine the function, you know that when x is lying from inclusive 0 till open bracket 1, the whole value of y will be just 0. Therefore, the greatest integer function's value itself, says the greatest integer function of x value itself will be 0. And hence the function itself will become 1 plus x. So like that I am trying to redefine the function from close bracket 1 to open bracket 2. During this interval I know that it's going to be 1. So when greatest integer function itself happens to be 1, so then the function therefore is 2 plus x, and from a close bracket of 2 alone, because it only extends from close bracket 0 to 2. So at x is equal to 2, the greatest integer function of x will be 2, and so then it's 3 plus x, and thus you can redefine g of x. And the next function is simply a 2 plus x, and there's no redefining. Let's define the third function, which is h of x, which is x plus 2 into greatest integer function of x. And when you redefine them, again you have to do 0 to 1, the greatest integer function's value will be 0, and so then therefore it will be just x. When x is lying between close bracket 1 to 2 open bracket, greatest integer function's value will be 1, so then therefore it will be greatest integer function will be 1, so it's x plus 2. And when it is at x is equal to 2, greatest integer function itself will be 2, and so then this is 2 to 4, 4 plus 2 6. So this is not a function of x, because we know x itself is 2. So here also again it is directly a function of, not a function of x, it's because x itself is 2, so you can just substitute. So this is 2 plus x, and this there are 3 equations, and so this at x is equal to 2. So now that you know these 3 equations or what is coming, and the maximum of this, can you see that the maximum of this function occurs at x is 6, because even if you substitute 1 to 2, 0 to 1, 0 to 2 any value, it's still going to be less than 6, so you get maxima at 6. So maxima occurs at 6, and this is actually occurring at x is equal to 2. So then therefore you understand the maxima is occurring at 2, which is just one point which is not differentiable. At maxima it will not be differentiable. It will and okay, what was the point is about continuity. I'm sorry, its point is about continuity, and f of x gets discontinuous at x is equal to 2, because when x is equal to 2, you get this to be 6, and x is equal to 2, you get this to be 5, when x is equal to 2, this gets to be 4, and you have different values. Okay, so then when x is equal to 2 plus 2 plus, yeah, so then therefore you get different values of f of x. And so can you see that the limit is changing? You understand that a 4 is not equal to 5 is not equal to 6 at x is equal to 2, so then therefore the limit does not exist at x is equal to 2. So then therefore m is the number of points, so m is equal to 1. And then is about differentiability. When you're talking about differentiability, you see that every function has got slope as 1. So it seems to be like it is differentiable at every point. So where it is not differentiable, therefore n is equal to 0. Not differentiable is n is equal to 0, because it seems to be differentiable at every point, and at every point you are you can't include a 2, because at 2 it's getting different values, it's not continuous, so you can't check for differentiability. But other than 2, if you see like open bracket 0 to 2, let's put open bracket 0 to 2, it is definitely differentiable at every point. What about at 0? At 0 you get different values of functions, that's okay, but the question is about differentiability. You get slope to be 1 at all other points, correct? Yeah, therefore the slope is the same, and therefore it's differentiable other than 2, it's differentiable everywhere. That's what I would like to say. Okay, from open, they have themselves given at 0 to 2, so it's convenient for us. So then n is equal to 0, the point where it's not differentiable. So number of points where it's not different, m plus n the whole square plus 2, and m is equal to 1 plus 0 the whole square plus 2, therefore the answer will be 3. That's all. Such a beautiful sum. Okay, the next question that we learned today is limit of x tends to 0, e to the power ax minus cos bx minus cx into e to the power minus cx by 2 by 1 minus cos 2x. This limit itself is 17. Okay, so while solving this, they have given some options. Okay, how to do this sum is only by using Taylor series, because this is something that we don't learn in 12th for board exam. So you have to know Taylor series to be able to solve this sum. A Taylor series is there for e to the power x, for cos x, and for e to the power minus x. Let's take e to the power ax and a cos bx and e to the power minus cx, or the three different series. So normally when is e to the power x, you know it's 1 plus x square by 2 factorial plus x cube by 3 factorial. It is ax. So you write as 1 plus ax the whole square by 2 factorial plus ax the whole cube by 3 factorial, and so on. And for cos x, for a simple cos x, you should know what is the Taylor series. Cos x is 1 plus x square by 2 factorial plus x cube 1 minus alternatively plus x cube by 3 factorial. So alternatively minus and plus for cos. We'll discuss about other Taylor series. For now, let's remember 1 minus bx the whole square by 2 factorial plus dot. You can ignore the higher powers when you're doing it. And for exponential, you know that it's already the first equation with alternative negative sign, because minus cx. So 1 minus cx plus cx the whole square by 2 factorial, and so on. Actually, in fact, they won't even write the next term. That's all. This is the series. And so on applying this series in our equation, you get limit of x tends to 0. And let's apply the Taylor series for e to the power ax, which means you're going to write this equation, which consists of 3 terms, 1 plus ax the whole square by 2 factorial, and that is done, and minus cos bx. So minus of the cos bx itself is 1 minus bx the whole square by 2 factorial, and that is enough. Minus for the next one, if you see the cx by 2 is already there, just write the cx by 2 and write 1 minus cx plus cx the whole square by 2 factorial dot. It goes on, but we can still ignore all those higher powers, and thus simplifying, you know, this 1 and this minus 1 get cancelled. You can consolidate x and x. So when you do that, x and x, so then it will be, you have an x into a plus c by 2 plus, let's consolidate all the x square. So you have an x square by, can you see, an x square into a square by a square plus b square plus c square by 2 factorial, which is just 2. And so thus you've consolidated, and you know the denominator is 1 minus cos 2x, which is 2 sine square 2x. So multiplying, dividing by 2x, 2 sine square, no, 2 sine square x. So multiplying, dividing by x square. So then x square, this will become 1. So you'll be left with an x into a plus c by 2 plus x square into a square plus b square plus c square by 2 by a 2x square itself is 17. They themselves have given it. So when you take it that side, it will become 17. Was it 17? Yeah. So 34x square is all you get. And now you can imagine this is 0x plus 17. No, that's all. No constant at all. Equating the coefficient x, coefficient 0. So a plus c by 2 is equal to 0. A is equal to minus c by 2, or c is equal to minus 2a. And similarly, equating the coefficient of x square, c square by 2 is equal to 34. So a square plus b square plus c square is equal to 4 to 8, 3 to 68. And c itself is minus 2a. So a square plus b square plus 4a square is equal to 68. 5a square plus b square is equal to 68. And that's exactly what you need to prove. I didn't write the proof though. Let me tell you that the proof for this sum is this, where you have to prove that find 5a square plus b square is the question. So thus you find this. I hope it is useful. It's very, very interesting.